So here are our three basic trigonometric identities. We have our right angle triangle. The length that's opposite the angle is called the opposite. And the other length here is called the adjacent because it's adjacent to the angle. And the longest length here is called the hypotenuse. The sine of our angle theta is the ratio of our opposite to our hypotenuse. The cosine of our angle theta is the ratio of our adjacent to our hypotenuse, and the tangent of our angle theta is the ratio of the opposite to the adjacent. So let's go ahead and we'll do three examples here. So let's go through these three examples. We have a right angle triangle. We have a length of 8 and an angle of 30 degrees. Now in these examples we're dealing in degrees, not in radians. So if you've got your calculator and you're going to work through these, make sure your calculator is sitting in degrees mode. And we're looking to find the value of x. So this is the angle that we have, and if you were to go opposite the angle, then this x would be the opposite. So we could write the value of x divided by 8, so that's the ratio of our sides, is going to equal, well, the x is the opposite. If that's the opposite, then this length here must be the adjacent. So the opposite over the adjacent is the tan function. So that's going to be tan over angle, which is 30 degrees. So we can write that x upon 8 is equal to tan of 30 degrees. So therefore we can write that x is equal to 8 times tan 30 degrees. Now you can go and get your calculator, or if you like you can use an online calculator. So that's the calculator. I just went into Google and typed in calculator and it gives us this calculator here. So we're looking to do 8 times tan 30. So we put in 8 times, and we have our tan, and we have 30. And you can see I've chosen degrees here, okay? So the answer to that is going to be 4.62. So x is equal to 4.62, and we can double underline it. Now the next one we're looking to find the length x. So you can see here this is the angle we have. So opposite the angle is going to be the opposite. So we're going to have x upon 24 is going to equal, well, that's the opposite, and the longest length here must be the hypotenuse. So opposite over the hypotenuse is equal to a sine function. So that's the sine of 55 degrees. So we can say that x over 24 is equal to sine of 55 degrees. So therefore we can say that x is equal to 24 times the sine of 55 degrees. And again, if we put that in the calculator, so we're going to have 24 times sine 55. So we'll have 24 times the sine of 55 degrees. And that's equal to 19.66. So x is equal to 19.66. And finally, we have the angle here, 71 degrees. So the opposite must be this side here. So if that's the opposite, then this must be the adjacent, and this must be the hypotenuse. So we can say then that the ratio x upon 60 is equal to the adjacent over the hypotenuse, which is the cosine function. So that's cos of 71 degrees. So we can say that x upon 60 is equal to cos of 71 degrees. So therefore we can say that x is equal to 60 cos 71 degrees. So again, we'll go into our calculator and we'll put in 60 cos 71 degrees. So it's going to be 60 times the cosine of 71, which is equal to 19.53. Okay, so we'll have x is equal to 19.53. So those are three little examples, and hopefully you've seen these before, and this will really just be a little bit of revision. So if you're interested, there's a few other examples in the notes at the back of the course if you want to go ahead and try some more. So thank you for listening. I'll get you on the next video. Goodbye.